Now we're going to learn how to graph logarithmic functions. For our first example, the goal is to graph log base 4 of x. To do that, we will use the exponential function 4 to the x power. Remember, logs and exponentials are inverses, which mean the x and the y values switch. Since exponentials are much easier for us to evaluate, we'll start by evaluating the exponential and simply flip the x and the y to get the log function. For exponentials, we sub in -2 to 2. 4 to the -2 power would be 1 over 4 squared, which is 1/16. 4 to the -1 power is 1 over 4. Anything to the 0 power is 1. 4 to the first power is 4, and 4 squared is 16. Which means for our log function, the x values are 1/16, 1/4, 1, 4, and 16, and the y values are from -2 to 2. As a reminder, the domain for an exponential function is all real numbers. The range is greater than 0. The y-intercept is 0, 1. And the asymptote is at y equals 0. For our log function, the domain and range switch because the x and y values are switching. So our domain is x is greater than 0. We cannot input a negative value into a log because we do not get a negative value out of an exponential. Our range, however, will be all real numbers. Remember, the answer of a log is the power. You can put any number as a power, which means you can get any answer to a log. Instead of a y-intercept, we have an x-intercept, and our asymptote will be x equals 0. Either way, I can't fit 16 on my graph, so I'm going to scale each of these by 1s so that we can see a little bit of detail between the exponential and the log function. I'm going to graph both of them for you so you can see that reflection over the line y equals x that we get when we graph inverse functions. Starting off, we had -2 1/16. For the exponential function, we had -1 1/4, 0 1, and 1 4. Again, that asymptote is the x-axis or the y equals 0 line. For our log function, we had 1/16 -2, 1/4 -1, 1 0, and 4 1. My line looks slightly like it is on the y-axis. That is actually an asymptote, but remember those values get smaller and smaller and smaller and closer to that asymptote to the point where our eyes can't tell the difference. So I would rather have you put your line on the asymptote than curve away from it, which is a tendency of students when they know that there is an asymptote to the graph. I'm going to sketch in that y equals x line. You can see very clearly that the exponential function, our red graph, is a reflection of the log graph, the blue graph. Next, we're going to take a look at some transformations of log graphs. All of the properties of transformations that we saw with other functions back in Unit 2 will be the same properties for transformations of log functions. We're going to stay away from scale changes. As graphing logs is new to you, we'll start with the basics. So horizontal shifts move the graph left or right. Of course, they will be grouped with the x, which means in the asylum, so they're not normal, so they act differently than we expect. If it looks like it's going left, there's a negative inside, then it will actually be shifting to the right, and vice versa. If it looks like we're shifting right, it will actually shift left. Vertical shifts are normal. They will not be grouped with the x. We have to use parentheses to group it with the x, which is a nice thing about logs. So if it is outside of the asylum, then it is normal, and it goes up if it's adding and down if it's negative. And finally, we'll have some reflections. So if the entire function is being multiplied by a negative, that is a vertical reflection, which flips it across the x-axis. If the x is negative, that is a horizontal reflection, which flips it across the y-axis. Let's take a look at the transformations for this graph. First of all, we have multiplication by a negative. It is outside of the log function. The entire function is being multiplied by a negative, so that's a vertical reflection. Here, inside, grouped with the x, we have a -1. So that's a horizontal shift, opposite from what we think, so it's going right 1. And this is outside of the grouping with the x, so that is a vertical shift, and it's normal, so we're going up 2. For transformations, it may be easier to look at the domain, range, x-intercept, and asymptote from the graph, so we'll start with our t-charts. First of all, we're going to get that parent function, which is log base 4. The easiest way to fill out a t-chart for a log function is to actually fill out those y values, the -2 to 2. Remember, these are the exponents for 4 to the x power. Then we'll fill out the x column with the answers. That's what you take the log of. The answer of a log is the power. The answer of an exponential is the x value of a log. So 4 to the -2 power is 1/16. 4 to the -1 power is 1/4. 4 to the 0 power is 1. 4 to the first is 4. And 4 squared is 16. For the second t-chart, we're going to put in all of those transformations. First, we had a vertical reflection, which multiplies our y by a negative. Then we identified going right 1, which was a horizontal shift. And finally, up 2, which was a vertical shift. So we're going to take those parent function t-chart values and transform them to get our new log function, adding 1 to all of those x values. Order of operations for our y's, we will multiply them by a negative before we add 2. So the opposite of -2 is 2, plus 2 is 4. The opposite of -1 is 1, plus 2 is 3. 0 plus 2 is 2. -1 plus 2 is 1. And -2 plus 2 is 0. Plotting those points, since 17 won't fit on the graph either way I scale this, I'm going to go ahead and scale each of these by 1. So 1 and 1/16 up to 4. 1 and 1/4 up to 3. 2, 2. And 5, 1. Remember, we had a vertical reflection on this one, so that's why it kind of is looking like an exponential graph instead of a log. It flipped the log function vertically across that x-axis. However, notice that our asymptote is a vertical asymptote, not a horizontal, so that'll help differentiate between an exponential and a log function. Let's go back up and hit domain and range as well as those other values. For a log function, the domain is restricted. In this case, we shifted it right 1, so that shifts our domain right 1 as well. X is greater than 1. That also gives us our asymptote, x equals 1. Our range is always all real numbers for a log. That will never change with any transformation. And we can see from our t-chart, we found our x-intercept. Remember, an x-intercept occurs where y is 0. So we have an x-intercept at 17, 0. Last example, we have a reflection again. This time it is a horizontal reflection because it is being grouped with the x. We also have this -3, so it looks like we're shifting it left. We're actually shifting it to the right. Again, we'll come back to that information after we get our graphs. Parent function, this time it was log base 3. That doesn't change those y values. We're still going to keep those y values from -2 to 2. But as we solve for our x values, we are using 3 to the -2 power, which is 1/3 squared, or 1/9. 3 to the -1 power is 1/3. 3 to the 0 power is 1. 3 to the first power is 3. And 3 squared is 9. Using those transformations we identified, we had a horizontal reflection, which multiplies our x by a negative, as well as a shift right 3, which will add 3 to our x values. All of our y values will remain the same. We didn't have any vertical changes to this graph. So negative 1/9 plus 3 is 2 8/9. Negative 1/3 plus 3 is 2 2/3. Negative 1 plus 3 is 2. Negative 3 plus 3 is 0. And negative 9 plus 3 is negative 6. Keeping all those y values the same. Even though I could fit that negative 6 on if I scaled each of these by 2, I'm going to stick with a scaling of 1 for consistency as well as to make those fractions a little easier to graph. So we're going to start at 2 8/9, which is almost a 3, and then down to negative 2. Then we had 2 2/3 down to negative 1, 2 0 0 1. And then we could throw that negative 6 off the graph just to give us one more point to head towards. Remember, log functions have a vertical asymptote. So when you're sketching this, make sure you show that vertical asymptote in your graph. Going back up to fill in those details. Domain, this time, because of that horizontal reflection, we have x is less than 3, that horizontal shift that we identified. Range is always all real numbers. We found our x-intercept in our t-chart as well, where the y value is 0. And the asymptote comes from the shift as well, the horizontal shift. Vertical shifts do not change an asymptote for a log function, just horizontal shifts. And you have a U-try question? Please come to class with any questions that you have. Try this to the best of your ability so that you can see where you made your mistakes, if any, and then you'll know how to fix them.